All right, let's dive right in. We're going to tackle one of the biggest, most ambitious questions in all of science. We're talking about the hunt for a single beautiful theory that explains our entire universe, everything from the tiniest particles to the biggest galaxies. This is the search for a theory of everything.
So let's just start with a question to really get your mind spinning. What if we, with our 3 dimensions of space and 1 of time, are basically like ants crawling on a leaf? Completely oblivious to the vast, higher dimensional world that's all around us. It's a pretty wild thought, right? And it's at the absolute heart of the theory we're going to explore today.
Now, before we get too lost in the cosmos, we need to talk about a guy named Wolfgang Pauli. He was a brilliant physicist, but also brutally honest, and he had this famous insult for ideas that were so speculative you couldn't even test them. He'd say they weren't just wrong, they weren't even wrong. For him, if you can't prove a theory false, it's not even science. It's a really high bar, and it's a critique that hangs over this entire story. Okay, first up, let's take a little trip to the graveyard of theories. Because, the history of science is just littered with amazing ideas that, turned out to be wrong and got left behind. Just look at these two. For a really long time, scientists thought fire was caused by something called phlogiston being released. It made perfect sense. And the steady state model, that was a serious contender to the Big Bang. The idea was the universe was eternal, always looking the same. But as we got more evidence, both of them just fell apart. It's a super important reminder. Even the most popular, common sense ideas can end up in this graveyard.
So that brings us to a more modern idea, string theory. Back in the 80s, it was the big hope for a theory of everything, a way to finally connect gravity with the weirdness of quantum mechanics. It looked incredibly promising, but then a really strange problem popped up.
The number 5. Yeah, just 5. See, the whole point of a theory of everything is that there should be just one. It's supposed to be this single, unique answer. So you can imagine it was a bit of a shock when physicists realized there wasn't just one version of string theory, there were 5 of them. And here they are. All of them worked in 10 dimensions, all of them were mathematically perfect, but they were all slightly different. So the huge question became, if string theory is right, which one of these 5 is the one that actually describes our universe? I mean, having 5 theories of everything is kind of a problem, right? It's 4 too many. But this puzzle, it didn't kill the theory. Instead, it led physicists to an absolutely stunning realization. What if these 5 theories weren't in competition at all? What if they were just different windows looking into something much, much deeper? You've probably heard the old story about the blind men and the elephant, right? One guy touches the trunk and says, "It's a snake." Another touches the leg and says, "It's a tree." A third feels the tusk and thinks it's a spear. They're all technically right in a limited way, but none of them can see the whole picture, the elephant. Well, in 1995, a physicist named Edward Witten came along and basically said the 5 string theories are like the blind men, and the elephant, that's a single, more fundamental theory he called M-theory. This master theory doesn't live in 10 dimensions, but in 11. The 5 string theories we knew about were just different ways of looking at this one single reality. As for the M, well, he left it open. It could stand for mystery, magic, or, as we'll see, membrane. So how in the world does one theory become 5? Well, hang with me here. Imagine M-theory's basic objects aren't one-dimensional strings, but 2-dimensional membranes, kind of like a sheet of paper. Now, imagine one of those 11 dimensions is curled up into a circle so tiny we can't see it. If you wrap that 2D membrane around that tiny dimension, what do you get? It looks like a one-dimensional string. And depending on exactly how you do that wrapping and looking, you get the 5 different string theories. It's an absolutely beautiful and ingenious idea. Okay, this is where things get really, really weird and amazing. This idea of membranes, or brains for short, leads to one of the most radical questions in all of physics. A question about the very nature of our existence. Think about a water strider, one of those little bugs that skims across the top of a pond. To that insect, its entire universe is the 2-dimensional surface of the water. It has no idea about the deep water underneath or the huge sky up above. Well, what if our entire 3-dimensional universe is just like that? What if we're living on a 3D brain, floating in a much larger, higher dimensional space? Now, this isn't just a cool thought experiment. This idea provides a brilliant potential answer to one of the biggest mysteries in physics. Why is gravity so incredibly weak? I mean, you can overcome the entire gravitational pull of planet Earth with a tiny fridge magnet. It's bizarre. M-theory's answer?
All the other forces are stuck to our 3D brain, but gravity is special. It can leak out into those extra dimensions, which spreads it out and makes it seem much weaker to us. This all sounds incredible, right? It's elegant, it solves huge problems, but we have to come back to Wolfgang Pauli and his ghost. Is this real physics, or is it just a beautiful story we're telling with math? Can we actually test it? Because if we can't, we run the risk of it being not even wrong. So, this is the most powerful tool we have right now, the Large Hadron Collider, the LHC. It's an absolute marvel of engineering that smashes particles together with about 13 trillion electron volts of energy. It lets us see what the universe was like a fraction of a second after the Big Bang. But here's the kicker. To directly see the strings or extra dimensions that M-theory predicts, we'd need to reach something called the Planck energy. Just look at that number. It is about 100 million billion times more powerful than the LHC. Building a machine that powerful with today's tech would mean an accelerator ring bigger than the orbit of Mercury. It's just not happening. And so, there it is. Pauli's famous criticism just looms over this whole beautiful idea. If there's no way to ever directly prove it, does M-theory belong in the graveyard of theories? Is it just a gorgeous mathematical dead end? For a long time, that was the big worry. It seemed like we were stuck. But then, a massive breakthrough came from a place nobody expected. Not from an experiment, but from the strange world of pure mathematics. It was like finding a Rosetta Stone that could translate between two totally different languages.
So, in 1997, this physicist named Juan Maldacena was just playing around with the math of these brains and black holes, and he discovered this shocking connection, a duality. He found that two completely different kinds of universes were somehow mathematically identical.
Okay, so check this out. On one side of his discovery, you have a complicated universe with gravity, extra dimensions, and strings, basically something like M-theory. On the other side, you have a much simpler universe with fewer dimensions and absolutely no gravity. Just the kind of particle physics we know how to calculate. On the surface, these two worlds have nothing in common. And yet, and this is the incredible part, when you do a ridiculously complicated calculation in Universe A, and then you do the same calculation in the totally different Universe B, you get the exact same number, to incredibly high precision. This can't be a coincidence. It's like finding two ancient texts from opposite sides of the world that tell the exact same story word for word. It's a huge hint that these two different descriptions are actually two sides of the same coin. So this is where we're left. We have this absolutely stunning mathematical structure that ties everything together so perfectly, but we still can't test it directly in an experiment. So that brings us to the ultimate question. Is all this mind-boggling mathematical beauty a true glimpse into the deepest secrets of our universe? Or is M-theory just the most elegant, most beautiful theory ever to end up in the graveyard of science? Right now, that's the biggest mystery of them all.